7. Colorful fireworks often involve the decomposition of barium nitrate and potassium chlorate and the reaction of the metals magnesium, aluminum, and iron with oxygen. Cool. Letter A. Write the formulas of barium nitrate and potassium chlorate. Okay, so we have A, B, and C and D to do here. So at some point, I'm probably going to have to erase some questions. So just make sure that, pause the video when you want to, just to make sure that you write everything down. But for now, I have a little bit of room up here to write the formulas of barium nitrate and potassium chlorate. This is old news, right? We've learned this in chapter 2, I believe. Let's see. We have barium nitrate and potassium chlorate. Barium is in group 2 on the periodic table, right? Barium is a 2+ charge. It's in group 2. And nitrate is a polyatomic. Nitrate is NO3 with a -1 charge. You have to remember your polyatomics, okay, guys? You'll never be able to escape them in this whole course. Okay. So just remember that, once we have the charges, we just crisscross them to tell us how many of each we have, right? So the 2 crisscrosses and tells me that I need 2 nitrates, and the 1 tell me that I need 1 barium. So barium nitrate is Ba parenthesis NO3 2, right? Because if I have 2 polyatomics, I have to put that in parentheses. So barium nitrate would be Ba NO3 2. And I guess I'll just keep that here just to show my work. The next one is potassium chlorate. Okay. So just like before, potassium, we got to get the charges. So on the periodic table, potassium is K. It's a +1. It's in group 1. And chlorate is a polyatomic. Chlorate is ClO3 with the -1 charge. Gotta remember your polyatomics, mainly because they're not on the periodic table. You have to memorize them. Do our little crisscross method. The 1 from the potassium tells me that I need 1 chlorate, and the 1 from the chlorate tells me that I need 1 potassium. So no parentheses here. I have 1 and 1. So potassium chlorate would just be K, ClO3, and that takes care of letter A. Okay. Now let's go to B. B says the decomposition of solid potassium chlorate leads to the formation of solid potassium chloride and diatomic oxygen gas. Write an equation for the reaction. Okay, so I'm going to put B down here. Now, in words, let's just start with words, and then we can do the chemical equation, right? They said that potassium chlorate was decomposing, right? It's the decomposition of potassium chlorate. So I know that potassium chlorate, so I'll say potassium chlorate, decomposed and changed and formed, right? Leading to the formation, that means that you made, that means that you formed. Whew, too much talking. That means that you have to put a yield sign here. When you form or you make something, that just means that you're putting a yield sign. And what are you making? Well, you're making potassium chloride, right? That was one guy. So potassium chloride. And diatomic oxygen gas. So, and literally plus oxygen. Okay, so here's our equation in a nutshell. Now we just have to put the compounds in. Well, we already know what potassium chloride was. That was KClO3. And we just need to see if we need any more context. They told us that it was a solid, so I need to put an S here. S for solid. And that yields potassium chloride. Here is another formula, right, or a name that I have to get the formula for. Potassium chloride. Potassium, just like we said, was a +1. And chloride, is in group 17 or 7A. It's a -1. do your crisscross method, you have 1 chlorine, right? And you have 1 potassium. It's a 1 for 1. So here, it's just KCl. They told me that we're forming solid potassium chloride, so I know that this has to be an S for solid, plus oxygen. However, they told me that it was diatomic oxygen. Remember, di in chemistry terms means 2. Atomic means atoms. So you have 2 atoms of oxygen. So I'm not just going to put a O here for oxygen. I have to put a O2. It's a diatomic. I need 2 atoms of oxygen. And they tell me that it's a gas. So I put a G here for gas. And now I have a nice formula. However, once you make a formula, you got to make sure that it's balanced. So as I'm looking here, I see that my oxygens aren't balanced. I have 3 oxygens here, and I have 2 oxygens here. 3 and 2 do not match, right? And I can't multiply 3 by anything to get 2, and I can't multiply 2 by anything to get 3. A whole number, right? So what's the next number up? They both have 6 in common. If I take my 3 oxygens here and times it by what? What number would have to be here in order to get a 6? Oh, 2, right? 2 times 3 is 6. But then that means that I have to change this number, right? The coefficient in front of oxygen. 2 times what would get me 6? Oh, 3. So that's balanced. But now you just got to be careful. 2 KCl's, right, on the reactant side, but only 1 KCl on the product side. So what number would I have to put to get it to be equal to 2? I have to get a new number and put it here, right? Oh, I'm going to put a 2 here. And now everything is balanced. So this is your first balanced chemical equation. So if you want, write it down. But that's the answer for B. Yeah, I'm going to erase this. So just pause the video if you need, if you need to write anything down. But here we go. I hate to see my work go, but it's got to happen because we need new room for new stuff. Okay, so let's do the third one. Now, the decomposition of solid barium nitrate. Ooh, why is that so small? Here we go. The decomposition of solid barium nitrate leads to the formation of solid barium oxide, diatomic nitrogen gas, and diatomic oxygen gas. Write the equation for this one. Okay, so let's do the English terms first, and then that will lead us to getting the actual formula. They're saying that barium nitrate is now decomposing. So I know that barium nitrate is what we started with, right? This is the thing that is decomposing. And once it decomposes, it will lead to the formation you're making. So that means that I need a arrow. And what are you actually forming? Well, we're forming barium oxide. So that goes here, right? Diatomic nitrogen gas, so plus nitrogen, plus oxygen. Now we just have to write the formula. Well, we already did barium nitrate in the beginning, right? Barium nitrate was BaNO3 So BaNO3 Did they give us any more information? They said that it was a solid. So I'm just going to put an S here. And that leads to the formation of, it makes barium oxide. So I got to know what barium oxide is. Barium oxide, or I'll put it on the top here. Actually, I'll do it down below here. Barium, just like we did before, barium was a 2+, and oxygen is a 2-, right? So when you crisscross these, it looks like I need 2 oxygens and I need 2 bariums. But remember, for ionic equations, you always have to simplify this to the least term that's favorable between them. 2 and 2 breaks down into 1 and 1 because I can divide both numbers by 2 and I get 1 and 1. So barium oxide is really just Ba. Oh, they tell me it was a solid, so I have to include that information. And now I'm just going to continue. Plus nitrogen, they said it was a diatomic. Remember, diatomic means 2 atoms. So it wouldn't just be just an N, it would be an N2. They say that it was a gas, so I'm just going to include that information. And then plus diatomic oxygen gas. So I have O2 as well, and that's a gas, so G. Okay, now I just got to balance. So let's see. I have 1 barium on the left. I have 1 barium on the right, so that looks balanced. What about the nitrogens? Well, I have a nitrogen in here. There's 2 of them, so I have 2 nitrogens on the left-hand side. And I have 2 nitrogens on the product side, so that's balanced. And now let's see. I have oxygen on the left. I have 3 times by 2, so I have a total of 6 oxygen on the left-hand side. I have 1 oxygen, right? But then I need to add it to a 2, right? Looks like I have only 1 plus 2. I have 3 total oxygens on this side. So that's not balanced. So I do need to balance the oxygens out, right? So let's see here. It looks like this is the problem, right? This is giving me the odd number because 1 plus 2 is giving me a 3. So the first thing I want to do is I want to correct this odd problem, right? This is giving me a even number. I want to get my even number on the product side. So I'm just going to put a 2 in front of here. Now this is all about guessing and checking. So I'm going to put a 2 here. And that's going to upset my barium amount, right? I have 2 barium here now. So what am I going to have to do here? I had 1 here, but now I need to put a 2 here. You might be thinking, why are we doing that? But that was the only way, or one of the ways, in which you could get rid of your odd problem. Now, if I just add my oxygens, I have 2 plus 2 is 4. So now let's see how many total, Let's see how many total oxygens we have now. We said before that we had 6 here. Times 2, we have a total of 12 oxygen on the left side. And balancing the equation, I need to have 12 oxygen on the right side. There are 2 oxygens here plus something to get me to 12. You could write this as a chemical equation, right? Or a mathematical equation. 2 oxygens plus some number times 2 will have to get me to 12. So if I do that, I have 2 oxygens coming from this guy plus, literally plus, 2 times what? I don't know that number. Will get me to equal to 12. And if you see this math, right? If we minus 2 on both sides, we get 2x equals 10. Divide by 2, divide by 2. We know that I need a 5 here. Now, you probably could have done that without doing the math, but I just wanted to show you. And now let's just see if the nitrogens are balanced. I have 2 nitrogen on the reactant side. There was a 2, but now I'm multiplying it by 2. So I have 4. What number in front of here is going to get me 4 nitrogens? 2 times what? Oh, 2 times 2. And now everything is balanced. That's the answer for C, okay? So 2BaNO3, 2 solid, yields 2BaO solid plus 2N2 plus 5O2, and that is your answer for C. Now let's see here. For D, and let's just erase this. So pause the video once again if you need to. I'm just going to erase this, just so that I have room for D. And then let's just see what D is all about. Okay. So D says, write separate equations for the reactions of the solid metals, magnesium, aluminum, and iron with diatomic oxygen to yield the corresponding metal oxides. And we need to assume that the iron oxide contains Fe3 plus ions. Okay. So another equation, right? We're taking our solid metals, magnesium plus aluminum. Oh, we need to write separate equations. Okay. So we have to do one metal at a time. We have to do magnesium reacting with oxygen. We have to do aluminum reacting with oxygen. And we have to do iron reacting with oxygen. So I think I can actually do this all in one shot. Okay, so here, we're going to first react magnesium with oxygen. Okay. Magnesium is Mg, right? And it's a solid metal, so Mg would just be a solid. And you're reacting it with oxygen, and they said that it's a diatomic, right? Diatomic oxygen. So we know that the oxygen has to be O2. They're saying that it's a gas, so G. And that's yielding or making or forming. Anytime that you do the arrow, it's a yield symbol. And we need to make the corresponding metal oxide. In this case, you're putting together magnesium with oxygen. So it would be magnesium oxide. So just like we've been doing the crisscross method, we got to do it here. Magnesium is Mg, it's a +2 charge. Oxygen is oxygen with the 2- charge. If we crisscross these, you have 2 oxygens and you have 2 magnesiums, but you got to simplify, so I could divide both by 2 to tell me that it's a 1-to-1. So this would just be MgO. And these metal oxides, I think they should be solid. They don't say, right? Write separate equations for the reactions of these solid with to the yield to corresponding metal oxides. These should be solid. So I'm just going to put an S here. Now we just have to balance. So the problem here looks like there's 2 oxygens, right? And I only have 1 oxygen here. What number am I going to put here that will get me to 2? Oh, 2. But if I have 2 oxygens now, I have 2 magnesiums as well. And I only have 1 here, right? So what number am I going to put in front? Oh, a 2. And now this one is balanced. So this is the first equation, the magnesium and the oxygen one. Now we have to do aluminum with oxygen. So I'm just going to erase a couple things, so pause it. Pause the video if you need to. I'm just going to erase away. So actually, this, whoop. Okay, and then all of this goes bye-bye because we have a new compound. The only thing that's basically staying the same is the oxygen. But in this case, for the second one, we need to add aluminum or aluminium. For all you there across the pond. We're going to form the metal oxide, which is aluminum oxide. Aluminum oxide, right? And aluminum we know is Al. It's a solid, so that's just an S. But now we need to do the crisscross method to find out aluminum oxide. Aluminum has a +3 charge. It's in group 13 or 3A. And then oxygen, like we said before, is a -2. So if we crisscross, turns out that I need 3 oxygen and I need 2 aluminums. I can't simplify this, so this would just be Al2O3, and technically this should be a solid. Now let's see if we can balance it. Well, I have 2 oxygens here, right? I have a 2 here. I have a 3 oxygens on this side. We run into the same problem as we saw before, but that's okay because the common number is 6. I will put a 2 in front of the Al2O3. That will give me 6 oxygens. And I will put a 3 in front of the O2. That will give me 6 oxygens. But now let's just check if the aluminums are balanced. There's a total of 4 aluminum here, right? 2 times 2 is 4. There's only 1 here. So what number am I going to put in front? A 4. And now it is balanced. And that's it for the aluminum one. Now we got to do the same thing again for, last but not least, the iron. Okay? So it's still reacting with oxygen, so that doesn't change. The coefficient might change, but the actual oxygen, the actual O2, does not change. Let's see. Oh, cut it off a little bit, but that's okay. So now let's just change this up. Okay. So now we're reacting iron with oxygen to yield iron oxide. Well, iron on the periodic table is Fe. That is a solid. So Fe plus O2 will yield iron oxide. Now, iron oxide is a transition metal. It has many different oxidation states, so they would have to tell us, and they did. Assume that the iron oxide contains Fe3 plus ions. So iron would be Fe3 plus. If they didn't tell you this information, technically you could have used any charge, like a +2. But they specifically want the +3. The oxide, oxygen, we said was a -2. So crisscross, 3 oxygens and 2 irons. So this would yield Fe2O3. And that's a solid. Let me just erase this, just so that we have more room here. I think you guys got it by now. And it looks like the same problem happened as last time. This is a solid, so let me just put that there. And if I'm going by the oxygens, right, I have 2 oxygens, I have 3, so I'm going to put a 3 in front of the O2 to get 6, and then I'm going to put a 2 in front of the Fe2O3 to get me 6 oxygens, 2 times 3. And then let's just balance those irons. I have 2 irons here. 2 times 2 is 4. So what number should I put here? Oh, a 4. And that's it. So those are your 3 separate equations, okay? I just had to erase because we didn't have too much space. But we did one for magnesium, we did one for aluminum, and we did one for iron. So that all checks out. Guys, what do you think? This one was long, but it went through a lot of balancing notation. We did some of Chapter 2 stuff. Chemistry is very cumulative, all right? So just make sure that you know your polyatomics, the crisscross method, and we're learning balancing equations. You guys got this, all right? Let me know in the comments if this helped you. Subscribe to the channel if you want to see more, chem videos. And as always, have a great day. Hang in there. Keep studying hard, all right? Do awesome on your exams. Rock those quizzes. And I will see you guys all in the next lesson. Take care. Bye-bye.